Hello, welcome, and thank you for joining today's online tech talk, planning and executing your database migration to the Amazon Relational Database Service, or RDS for Oracle. Let's jump right in. My name is Nathan Fuzzi, and I'm your presenter for this discussion. I'm a Principal Database Specialist Solutions Architect with AWS. I've worked at AWS for over 5 years at this time, and I've been working with Oracle databases for over 20 years. Anybody else out there remember Oracle Applications 10.7 character? Anyway, as a database solutions architect, I partner with the product and engineering teams that build Amazon RDS for Oracle. And it's my absolute privilege to partner directly with you, our customers, as you explore migrating your Oracle databases to the cloud and modernize your application architecture along the way. In this presentation, we'll set the stage with a brief overview of AWS's purpose-built database portfolio. We'll review what Amazon RDS for Oracle is and what it manages for you. Then we'll talk about planning your migration, as well as go deep on some of the actual mechanics of performing the migration. We'll cover a number of best practices and considerations depending on your chosen target platform, including RDS Custom for Oracle, which we announced in general availability at reInvent last year. If you don't know what RDS Custom is, don't worry, we'll cover that in some detail later in the presentation as well. As this is a tech talk, I will be going into some technical detail about the technology aspects involved in the presentation. Familiarity with standard Oracle database aspects will be very helpful in understanding the material, and as such, we expect that DBAs and DBA managers will likely get the most out of the session, as well as CIOs and CTOs. Well, what do we mean by a managed database? Are DBAs obsolete? At the risk of further dating myself, I remember when the IT director of my employer came into my office and slapped down a magazine on my desk with a cover story that asked, "Is Oracle 9i the end of the DBA?" As a DBA at the time, I can tell you that didn't feel good, but we all know how that turned out. And eventually people stopped asking that question with every new major version of the Oracle database, as it's clear there's still an enormous amount of work involved in managing and maintaining an Oracle database environment. But with the advent and revolution of cloud computing, we've developed ways to take on menial, tedious, error-prone tasks and improve the efficiency of DBAs and IT teams in general. Let's take a look. Here we have a graphical categorization of the broad array of managed database services that AWS offers today. From relational databases on the left to non-relational, in-memory, graph, time series, and ledger databases, AWS has developed managed solutions for a vast set of customer use cases based on what you've told us you need. The past 15 years have seen an incredible shift of all sorts of application workloads, from on-premises data centers or co-location facilities to cloud-based computing by using services from AWS. Companies have been able to innovate faster, serve customers better, and keep their IT spend lower by migrating to cloud-based computing. As you move to microservice architectures and build loosely coupled distributed components for your applications, having the right tool for the job becomes increasingly important. But managing that tool doesn't add value to your business. And that's where we can help with managed, purpose-built database platforms. For relational workloads in particular, the Amazon Relational Database Service provides a fully managed platform for you to run your database applications. And it supports multiple open source and commercial database engines. The service provides high amounts of automation of lower level provisioning and maintenance, and it also delivers some high value add features like managed high availability, disaster recovery, backups, and failover. It has granular monitoring and alerting capabilities and the ability to scale massively and in minutes with just a few clicks or a single API call. There's also Amazon Aurora, which is a MySQL and PostgreSQL compatible relational database built for the cloud with the performance and availability of enterprise databases combined with the simplicity and cost effectiveness of open source databases. We're seeing a huge amount of interest in migrating off of commercial engines to open source ones, and we have lots of resources available to you if you're interested in exploring that. But for this presentation, we're focused on migrating to Amazon RDS for Oracle, so let's look closer at that service. In your on-premises environment, you are responsible for every aspect of hardware and software maintenance, from procuring the servers to racking, stacking, and cabling, installing the operating system and the database software, and managing operational aspects like HA, performance scaling, and finally, application support and optimization. This typically means purchasing servers upfront and in a fixed configuration, probably with excess resources in case usage grows. Once that system is in operation, you'll deal with hardware maintenance, OS and database patching, and management and monitoring of backups. When you deploy this same database application to Amazon EC2, Amazon takes care of a large amount of that undifferentiated heavy lifting. We provision hardware to match your resource selections, and you specify the OS version for AWS to install on it and turn it over to you. From there, you install the database software of your choice, and you maintain the system similarly to one in your own data center. You manage OS and database patching, backups, HA and scaling, and of course, application optimization. Now, Amazon RDS takes this to a whole new level, where the service lays down a supported, configured, and optimized OS and the Oracle database version of your choice. It also provides managed updates of both the OS and the database as patch sets, and even new major database versions are released. RDS also automates daily backups and copying the database archived redo logs to enable point-in-time recovery. RDS provides HA and scaling features with just a few clicks, and it provides monitoring and alerting for all kinds of database events. So you, as the DBA, can focus your time where it most benefits your business, at that application layer, helping developers efficiently use the database and optimizing data structures and data access. Now, RDS Custom for Oracle, which we launched into general availability at reInvent 2021, provides similar provisioning and automation while allowing you full access to both the OS and the Oracle database with super user privileges. This means multiple aspects of RDS Custom for Oracle management are shared or customer managed today, where you can tailor them to your specific needs while still benefiting from the management and automation of RDS for your normal operations. RDS Custom for Oracle opens up a new set of Oracle database application capabilities and use cases, which are beyond the scope of this presentation, but it also opens up additional options for migrations, which we will cover later. What's different about RDS Custom? Well, for one thing, when you create a standard RDS Oracle instance, that instance actually runs in an AWS internal account, and you get access to the instance by way of an elastic network interface created in your Amazon VPC, which allows you to connect to the RDS instance as though it's local to your other VPC resources. And we do this largely to protect the instance and other resources from unauthorized access or changes outside the APIs defined for you to manage the instance. This keeps all configurations within expected ranges so that our automation and monitoring continues to work and your instance achieves maximum availability. With RDS Custom, we use a different deployment model. When you create the instance, you will see the EC2 instance in your account, along with the attached EBS volumes, snapshots, and IAM roles. You can even see the redo logs as they're copied to an S3 bucket in your account. You can SSH to the EC2 instance, and you can connect as sysdba to the database there. You can even attach an EFS volume for shared storage between the database and application servers. Normal database users continue to interact with the database through the RDS endpoint, but you have greater access for administration purposes. And we'll discuss the architecture and migration implications in greater detail later. But with multiple options available, you may be wondering, how do you decide which target platform is right for you? Well, here's a quick rundown. We recommend that you target your Oracle migration to the standard Amazon RDS for Oracle to get the benefit of maximum automation and management offload to the service. RDS for Oracle automates extremely advanced features like Oracle replicas and multi-AZ synchronous replication with a few clicks, and it can automatically apply Oracle release updates for you during your normal maintenance window. If you have special needs that cannot be supported by RDS Oracle, such as a requirement for sysdba or root access, or you want to manage your own HA or DR configuration, choose RDS Custom. RDS Custom also offers an option if you need to run an Oracle database version that has passed the end of extended support date from Oracle, such as with the 12.2 and 12.1 versions reaching end of support in 2022. We expect that RDS Custom will cover the vast majority of use cases and will provide substantial amounts of automation today with more to come. But there are still those customers who have special needs, such as an advanced storage configuration, or who want to do traditional bin packing, where you run multiple database instances on a single virtual machine. For those customers, running Oracle on EC2 may be the best option, where you will self-manage all aspects of the operating system, the database configuration, backups, HA, and disaster recovery. Okay, now that we've level set on the product we're looking to migrate to, let's talk about migration methods. There are three high-level categories of migration methods to explore here: an all-at-once, one-time migration, continuous replication that may happen over a much longer period, and periodic or transactional migration. Let's dig into each one. Conceptually, the one-time migration is the simplest. This means a bulk pickup and move, either with or without an application outage, depending on whether you can tolerate an incomplete data set on the target. This is typically well suited for small databases where the migration is quick enough that the application can support downtime for the entirety of the process to avoid failing to capture any changes generated along the way. It's also fine for proof of concept pilots where you just need a data set on that target, and it doesn't necessarily have to be transactionally complete. The one-time migration can also apply to the bulk of the data to be moved and serve as a starting point for continuous replication, which will then capture and migrate the changes that occur after the start of the one-time migration. Continuous replication, then, is built to handle databases that are undergoing change and need a complete data set on the target. These are either large databases that can't afford to be down for the time it would take to transfer, or mission-critical databases that have high uptime requirements and need near zero downtime for their migration. This type of migration mechanism is also useful for data protection and disaster recovery purposes, as it can provide a full physical copy with very little lag or delta between the source and the target. And if it's configured properly, it can sustain this like indefinitely, either until the planned cutover time or a disaster occurs on the primary. And then a periodic refresh also involves incremental updates, but not necessarily of a continuous nature. Say that you've already migrated the bulk of the data for a new environment, but now you want to refresh that environment with new sales transactions in the days since. You can perform another smaller migration of a specific data set, possibly based on date or specific partitions on the source, and catch up the target with the changes that have occurred since the original migration. This is similar in concept to an ETL process where you identify the changes and apply those changes to the target. Okay, so with those three basic types of migration available, how do you determine which you should use in any given use case? Well, some key considerations are the total number of databases you need to migrate. The difference between migrating a few databases and a few hundred databases can be a big determining data point in terms of how much automation you want to build around the migration process. Similarly, the sheer size of the database in question may force your hand, as large databases can simply be impossible to transfer over your existing network infrastructure in a reasonable time. Another question is whether you are changing the data at all as part of the migration. Migration time can be a good time to correct long-standing issues in data types or change the character set to something more flexible. Your network bandwidth and latency will play a role as well, as transferring a large amount of data over the wire may impact normal operations, which could cause application impact if not monitored and throttled adequately. And again, what is the acceptable application downtime for the migration? This, combined with other factors like the number and size of databases to move and available bandwidth, can affect the order and timing of databases to move at the least, and may well force you onto that continuous migration path for some databases. And lastly, RDS and RDS Custom do have some limitations, including a total capacity limit of 64 terabytes per instance today. You should research whether your database has specific requirements and that those are supported by RDS before beginning the migration. So what tools exist to achieve this migration then? Well, currently, RDS for Oracle supports logical migration only. For small and large data sets, Oracle Data Pump is a great tool to transfer data between databases and across platforms. For small data sets, you could also consider traditional export-import using materialized views and potentially database links to pull data over, or even SQL Loader. For larger data sets, Oracle Data Pump can export the data set, which can then be transferred over the network, or the resulting dump files can be copied to an AWS Snowball, which is an edge computing, data migration, and edge storage device that you can connect via local network to your database server to receive the exported data. Then you ship the device to AWS, and we will upload that data to your S3 bucket where you can access it and import it into RDS. You can also use the AWS Database Migration Service, or DMS, to perform a full load of your source database to the RDS instance directly. We'll talk about this in details in just a minute. AWS DMS can also perform change data capture, or CDC, of an Oracle database source to propagate the changes to the target RDS Oracle instance. It can do this in conjunction with a full load as well. Other logical migration and replication tools can also be used, including Oracle Golden Gate, Quest SharePlex, Attendees, or Click Data Integration, as it's now known, and others. We've covered the basic types of migration and the tools you can use to achieve them. Now let's talk about how you use those tools to actually perform the migration. You'll want to determine your migration method based on the factors we discussed earlier, settling on either a one-time or a continuous migration. After that, we recommend creating a test RDS instance and getting familiar with how to manage it and interacting with it. This can be a really small instance, so you can create it, connect to it, create some test data and query that, modify the instance, etc. And then once you're familiar, you'll want to size the RDS instance to handle the incoming data acceptably, which may involve scaling up the instance as well as the attached storage, so these are not bottlenecks that slow down the migration process. You may even consider oversizing the instance to make the data load and later index creation steps faster, with plans to scale the instance back down before putting it into normal operation. As part of this pre-migration, make sure you've secured the RDS instance, both in terms of database users and network access. You may need to open up additional ports for the data load or even create additional database users, depending on your chosen migration method. But be sure to log those so that you can close them down or disable them later. It's also a good time to take a snapshot or a backup of the instance at each logical checkpoint in the process, in case you later need to roll back some portion of the migration. You may be able to roll back only a small amount of changes by restoring a recent snapshot and thus save yourself some time. So let's walk through some migration scenarios. I do want to emphasize that these migration paths can apply equally to an Oracle database that is located in your on-premises data center, a co-location facility, or another cloud service provider. Starting with the Oracle database as a source on the left, you run an Oracle data pump to generate a set of dump files in that local environment. Once the export is complete, you transfer the dump files over the internet or through a VPN, landing them in your S3 bucket. From there, you can copy the files to your RDS Oracle instance storage, and then perform a data pump import into the Oracle database itself. For a larger source database or one at a remote location with limited bandwidth out of the data center, you'd follow a similar process using Oracle Data Pump to export the database to dump files. You would then copy those to the Snowball device and then ship the Snowball back to AWS. Once we receive the Snowball, we upload the files into your S3 bucket, and from there, you can copy the files to the RDS instance and then do the data pump import. For a continuous migration using AWS DMS, you'd first create the DMS replication instance, which runs in your Amazon VPC. You connect the replication instance to both the source and the target over the network. You define rules on the instance that tell DMS what tables, schemas, or data sets to replicate, and then you start the associated task to copy the data over, including creating the target tables on the RDS instance. You use DMS to capture changes and replicate those changes on the source database to RDS. Once the RDS instance is in sync with the source, you can switch over the applications whenever it's convenient to take a brief downtime. Let's look closer at how DMS actually works then. At a logical level, we have the source, the replication instance, and the target. DMS actually supports a large set of varied sources and targets, but replicating from Oracle to Oracle is very straightforward. If we explode the source and target databases, we can see that DMS actually transfers data and loads target tables in parallel. Data is loaded table by table, including loading 8 tables at a time by default. You can potentially increase performance of the migration by adjusting parallelism or by creating multiple tasks on the replication instance, each of which is set to replicate a different schema or a set of tables or even a set of rows. We recommend testing with your specific configuration and tuning the replication, both the instance size, the resources, the tasks, and the configuration, as well as the target RDS instance to reduce bottlenecks and achieve the desired migration time. For a full load, DMS scans each table and copies all rows in the table from the source to the target. But how does DMS capture the transactional changes from the source DB? DMS reads the source Oracle database redo logs, both archive logs and online logs, where Oracle records every transaction made on the database. As the application writes changes to the source database, the database produces log files. DMS either queries those log files on the source or physically copies them onto the replication instance and parses them there. Either way, it ends up with a set of transactionally consistent data changes that were made on the source database that it will apply to the target RDS instance. DMS can combine these two processes into one with a full load plus CDC. The full load would start copying table data in parallel from the source to the target via the replication instance. While that process is ongoing, the application continues to write new changes to the source, and these changes produce redo logs on the source, which DMS processes into change records, which it can then apply to the target RDS instance. Once the full load is complete and the CDC process is nearly in sync with the source, we get to the point of the cutover. But the application is still active at this time, generating additional changes on the source. So when we're at the moment of cutover, we need to stop application connections to the source database. Now we let DMS complete the capture of those last few changes on the source and flow them through to the target RDS instance. At this point, the source and the target are in sync. Now we can safely repoint the applications to the RDS instance and resume transactions. The migration is complete and we've achieved the cutover with minimal downtime. Now, coming back to RDS Custom, there are some architectural differences, and as we discussed earlier, these have implications in terms of migration options. Let's take a moment to talk about some of these architectural aspects and the terminology that applies to RDS Custom. First, with RDS Custom for Oracle, you bring your own media, meaning database installation files, as a base for the versions of Oracle that you will launch. This includes the standard database like Oracle 19c, as well as the release updates or RUs that you want applied, and any other specific patches that you require. From this, a custom engine version, or CEV, is created for each custom configuration. Once that CEV is created, it's available as a version for you to specify when you create a new RDS Custom for Oracle instance. If you think about it, this is similar to the process that we use on RDS for Oracle, where we allow you to pick almost any previous RU of the database version when you go to create it. Think of the CEV as your golden image. The next concept is automation mode. This is what controls things like monitoring, backups, and the database status. You can pause automation when you need to make a change that could interfere with or be interfered with by our automation, like applying a custom patch to a test instance. Once your changes are made, you can re-enable automation and return to normal operations with RDS Custom managing many aspects of the database instance. The last term we'll cover here is the support perimeter. This refers to the fact that you have the ability to make practically unlimited changes to your RDS custom instance and configuration. We can support the vast majority of these changes, but there are some changes you might make that could break our automation or monitoring. When you re-enable automation, we'll run a series of checks against the instance and notify you if your instance is outside the support perimeter so that you can investigate and correct the configuration. Full automation and monitoring of the instance is only possible when it's inside the support perimeter. Okay, so what does RDS Custom offer you in terms of migration capabilities beyond what we've already discussed in terms of logical migration to RDS Oracle? Well, in order to understand additional options, it's helpful to walk through exactly what happens when you create an RDS Custom for Oracle instance. First, the service will create a starter database of your custom engine version, or CEV, as we described on the last slide. Once that instance is available, or really any time thereafter, you may pause the automation in order to perform a physical migration of your existing database. With RDS Custom for Oracle, you have the option to attach an elastic file system mount point where your backup files or even existing database files reside. Once you have access to your existing database, you may initiate the physical migration using any of the mechanisms listed here or potentially others. Some methods include Oracle Recovery Manager or RMAN Duplicate Database, establishing an RDS Custom database as a DataGuard standby database, migrating a subset of a database using transportable table spaces, or even physically copying over the database data files and recreating the control file. Whatever physical migration path you choose, once the migration is complete, you'll need to recreate the RDS admin database user along with its required privileges that will allow the service to fully connect, monitor, and automate administration aspects as part of normal RDS operations. You can complete the switchover of a DataGuard standby or duplicate database sequence, or otherwise finalize and start up the replicated database. Re-enable automation, and you have completed a physical migration to RDS Custom for Oracle. I'll note here also that because you can use RMAN against a normal RDS Oracle instance, RMAN duplication or backup and restore may also be used to perform a physical migration from RDS Oracle to RDS Custom for Oracle if you find that you need to move to RDS Custom from standard RDS for Oracle. Now that we've covered the what and the how of migrating to Amazon RDS for Oracle, let's review some best practices for the process. First thing, don't unnecessarily bottleneck your migration by enabling features or functionality that doesn't add value at this phase. This really applies generally to any migration, but in particular, when migrating to Amazon RDS for Oracle, you want to turn off automated backups because they're not needed until you have valid data to back up. And because doing that will turn off archive logging for the instance also, which eliminates a lot of behind the scenes work for the database that isn't useful to have running until the migration is complete. Similarly, we strongly recommend running your RDS Oracle instance in multi-AZ mode with synchronous replication to a full secondary instance and storage in another availability zone for production workloads. But until your workload is close to production, meaning the migration is complete, running in multi-AZ is really only overhead and cost. So we recommend waiting until you're about ready to go into production to enable multi-AZ. The next point is creating indexes. Indexes are great for normal operations, but for the heavy writes experience during a large import of data, they require updating and thus are largely overhead that don't add value at this phase. Hold off creating them until the data is migrated, then create them in bulk. Compression and parallelism are your friends when dealing with large data volumes. Compression can make a huge difference in the database size as well as the size of the export files to write and transfer to the RDS instance. This can have implications on storage capacity and performance at multiple stages, as well as unnecessarily gobbling up network bandwidth. Optimize the volume of data to be transferred and then leverage parallelism to maximize utilization of your available resources and minimize migration time. Another aspect is instance sizing. If you have the resources, scaling up the target instance can help it to absorb more punches while migrating a bulk of data and shorten that migration time, even with a large data volume. This might even mean a larger configuration than you plan to run in production, but it could save you valuable time in shortening the cutover time. Enabling enhanced monitoring at a high granularity, like every 5 seconds or even every 1 second, may give you valuable insights into any performance bottlenecks on the RDS instance, allowing you to address the issue quickly and improve your migration time. For critical workloads, we recommend enabling enhanced monitoring for just this reason. So why not also have the benefit of it during an important migration? Lastly, pay attention to storage performance, both in terms of the performance capabilities of the RDS instance storage, as well as the instance's innate performance aspects. Larger instances are generally able to drive greater amounts of IOPS and storage throughput, which can be critical during an IO-heavy data ingest or index bulk build phase. Certain instance classes also have greater I/O capacity than others of the same size, so it's worth exploring the instance specs as you plan your migration. I mentioned earlier that the data pump dump files need to be staged on the RDS instance storage for import. Allocate enough space for those dump files and the expected database size before the migration. RDS Oracle offers storage autoscaling, but it's geared toward normal data growth, not many times capacity growth in a matter of a few hours. Allocate that storage ahead of time to make sure the migration goes smoothly. Understanding the migration time is also critical. You'll want to have executed multiple dry runs ahead of the actual cutover to have a good idea of how much time is required at each phase, and when you might need to take action if a stage is taking longer than normal. Just like enhanced monitoring of the instance aspects, keeping an eye on CloudWatch metrics for the instance and network utilization during trial runs and the actual run will help you identify issues early to potentially resolve them. In any case, testing and tuning of various processes will help you fit the whole process into the time window you have available. Post-migration, be sure to turn on automated backups, which will enable database logging. Test your application performance and tune the instance shape and storage type for the production workload as opposed to the migration. Production will almost certainly have a different workload profile than the migration phase, which could benefit from a different type or provision capacity, and the instance might benefit from more memory and more or less compute power. Enable high availability with multi-AZ at this point, and consider creating Oracle replicas either in region or in a second AWS region for both read workloads and for disaster recovery purposes. Amazon RDS for Oracle also provides cross-region automated backups to help with disaster recovery options. We urge you to explore the options available to see what configuration satisfies your recovery point and time objectives. Lastly, re-examine any network pathways you opened or user permissions you extended for the migration process and the tools used. Close any that are no longer needed and tighten permissions back to the normal operations least privilege access. I put together some links for features and aspects covered in this presentation if you'd like to learn more or do some targeted study of specific topics. These include both technical topics as well as the changing role of the DBA when migrating databases to a managed service like Amazon RDS for Oracle. And with that, I'd like to thank you for taking the time to learn about migrating to Amazon RDS for Oracle and RDS Custom for Oracle. We're extremely excited about these managed services, and it's awesome to be a part of our customers' cloud journeys and see how you use the services to benefit your businesses. I encourage you to work with your account team to engage a specialist if you have deep questions about the service or the migration process. They can also suggest AWS partners to assist you with planning and performing the migration when you're ready. Thank you again, and we'll address some of your questions in just a moment.